Just as an addendum to the bottom side of the board, we just have to fix some errors. 1. We have some bridging on the FTDI chip, so we just add some flux. You don't have to add extra solder, but I did on this side. Swipe it to the side, then just wick off the extra. The other side was just a quick wipe and wick. 2. A warning on the alignment of glued down parts. You must double check the alignment of the part from all angles before it goes in the oven. Because it's so hard to fix, it's practically only one shot to get it right. It's practically impossible without a hot air gun. You have to totally remove the part. You have to scrape the very hard glue off the PCB and part, or the part won't sit flat on the board. Wick off the pads. Repair parts that got accidentally dislodged. I went with thermal glue and made sure it was far away from the pads. A quick test fit and checking the underside of the IC that the glue is touching it, and refit. Tack the corners, then resolder the pins. What looked like a slight nudge to the left to fix ended up taking half an hour. 3. Upon reflection, these big black diodes look a bit heavy, so it's probably best to glue them down as well, which I didn't do in the last video. Next is a question of missing parts. I couldn't get confirmation why there's less parts in the kit than on the iBomb, so it's either this pre-sample kit didn't have all the parts, unlikely. The proper kit will have all the parts, probably not. The kit is right and you have to buy a few extras, maybe. The kit only has parts for the base circuit, not the options. This is most likely, but they don't tell you what options to remove from the iBomb. The first option that's not catered for is probably the onboard STM32, so this circuit could probably be removed. But even then it's not clear, because the kit has the crystal and a switch. These might be thrown in because they cost nearly nothing to supply, just in case you need the STM board. I would assume everything on page 10 of the schematic can be removed if you're using a plugged-in discovery board, and there has been steps taken in the Frankenso.csv BOM to tell you which parts are part of the STM board, but if some of those parts are in a group, like this 0.1 microfarad, there's no warning. You have to go to the Frankenso by ref.csv, and in here each individual part is separated, and it tells you which one is on the STM32. But even that is not good enough, because if you look at this C8, there is no warning, and you go to the schematic, C8 is in the STM32 circuit. It probably doesn't hurt fitting these parts if there's spares in the kit, but remember to give the base circuit part priority. But even the removal of the onboard STM32 circuit from the iBomb, it's still not enough. If you look at both sides of the boards, the total number of 1K resistors is 45. And in the Frankenso by ref CSV, there's 3 in the STM32 board circuit. So that means we need 42 1K resistors. But the resistor assortment only has 30 off of each value. And that means we are 12 1K resistors short. So there must be other circuits that are optional as well. Knowing this now probably means that I fitted parts to the bottom side that I didn't need to. Like if you look at the battery holder and the Frankenso bomb, it's part of the STM32 board. We've done the back side of the board, so now we select the front. Due to there being no compact iBomb just for the kit, we're going to have to fudge a few things, so I have to go through the list one by one. Start with capacitors. The first one is 0.1 micro or 100 nano, and there's 17 off. We subtract the 8.1 micros we found on the Frankenso by ref.csv, and that leaves 9, but the assortment only has 20 off and we used 12 on the bottom side. So we only have 8 left, leaving 1 short. Select front and back, and select which capacitor you want to sacrifice for which circuit. In this case it's most likely the 100 nanos that we fitted onto the bottom, because they're part of a circuit where the ICs weren't supplied. There are 4 of these circuits where we don't have the MAX 31855, so I would assume all the parts on these 4 pages are optional. It looks like it's for connecting a thermocouple directly to the PCB, maybe exhaust temp, so probably not needed. I'm fitting everything even if it's not needed, so I am supplying the extra 9 capacitors that are missing. Next is 4.7 micro, and that is not in the kit. The assortment is a low value kit and 1 micro is the max. Looking at the by ref, only 1 is attributed to the STM board. There's another 2 on the SD card module, another on the CAN level shifter, and the 5th one is part of the NOx sensor detect. If you need any of those, you're going to have to buy them. Next is do not populate, so we tick that off. On the NOx sensor circuit of page 5, it's this 1 capacitor and these 4 resistors. Next is 0.01 micro or 10 nano, They're not marked STM32, but they are on the STM32 page. There's plenty left over, so just fit them. Next is 2.2 microfarad, and they are marked STM32, so we can tick them off. If you need them, you're going to have to buy them because they're not in the kit. It's one of those high value ones over the max value of the assortment. Next is 1 micro, and they are marked as STM32, but since we have plenty left over, we're going to fit them. Next is 20 puff, and they are marked STM32. We do have 22 puffs, so I'm going to fit them. 12.5 puff is also marked as STM32. We have 12 puffs, so I'm going to fit them. 1000 puff or 1 nano and 3300 puff or 3.3 nano we have, so we fit them. 24 puff we don't have, but the 22 puff we do have, so we fit them. 0.022 micro is 22 nano and fit that. 4700 puff or 4.7 nano can be fitted. 10 nano we have a lot to spare, so we can fit them, even though they're part of the thermocouple circuits we don't have the chips for. Next is the 220 micro, which is the large yellow tantalums in the kit, and the 330 micro, which is the SMD electrolytic in the kit. Next is resistors. You need 24 1K, but the assortment only comes with 30 off of each value, and we use 21 on the back of the board. So we either have to buy another 15 or work out what we can fudge. We select front and back. We have this group near a bunch of MOSFETs, and on page 6 of the 12-channel injector driver, and the resistors look like some sort of pull down for the signal side of the MOSFET, and so are important. Next we have this group on the bottom side, and if we look at our 12-channel injector circuit, there are current limiting resistors for the indicator LEDs of the MOSFETs. LEDs are non-critical, so all of their current limiting resistors can be swapped out for something nearby. There's plenty 1.8K resistors. Blue LEDs are super bright and could use dimming, and 680 ohm. The LEDs blink, so should be able to handle this higher current. You can free up 12 by substituting the LED resistors. Another 3 are for the STM32 board, so that's the 15. Next was 20 ohms, which we substitute with 22 ohms, and there was enough left over in the assortment. Got 100 ohms, and 10K are in the kit. 2.7K, they are current limiting resistors for the LEDs on the high-low drivers, so you should be able to swap them out for something nearby. Maybe 2.2K or 3K. 39K and 680 ohm we have. 5K, here it says for R111 and 112. Resistors across pins 9, 10 and 15 and 16 are not typically installed. They are only used on really hot VR signals, so maybe leave them off. R170 is on page 5 and has something to do with the SPI. I'm not sure how that works, but a substitute of 4.7K might be okay. R161 and 162 1 meg do not populate. They look like pull downs on the knock sensor circuit. We tick them off because we're not installing them. 330R, 47 ohms, 100K and 2 meg are all in the kit. And now we come to 820R, which is not in the kit. If we go to R177, it's also a part of this knock sensor system, which is something I think most people won't have, so it can be skipped. Looking up the TPIC 8101 on the X out, which is the pin it's connected to, these values are a little bit different. 1 meg, 1K and 470 puff. This is 2 meg, 820R and 24 puffs. So it looks like this has been adjusted for a different case. It means this value might be critical. If you go to the 680 ohm or 1K from the kit, they're both out about 20%, which seems a bit high. So I don't know if you're supposed to use two resistors in series, like the 680 ohm and the 150 ohm, which makes 830 ohm, and then just stack them like a TP on the PCB. Or if you're supposed to use two resistors in parallel, like 3.9K and 1K makes close to 800 ohms, and stack them like a double decker. I actually had some 820s lying around, so that's the one I'm going to use. Next we have 1 meg and 120 ohms, which is in the assortment. You'll probably notice I'm fitting parts for the onboard STM32 but not mentioning them, and that's because it's easier to fit them than chase every single part when there's so many extras in the kit that you'll probably never use. I have to split this section into two because it's getting too long.